All right, so let's analyze a little bit more about the layers. The layers are data processing modules. Many different kinds of exist. There's different types of layers: densely connected, convolutional, recurrent, pooling, flattering, merging, normalization. So there's so many different types of layers that you can represent. The input can be one or more tensors. The output could be one or more tensors. Usually we have a state encoded as weights that learn initially is set up to be a random number. So the way we're gonna be able to learn, our value is going to be able to learn is by those weight values. Those weight values are going to be modified so that we can train our data. So the trained data will be modified by the weight values. Those are their parameters. When combined, we form a network or a model. So you can see here, you have multiple layers. We have multiple layers like a Lego. Sorry. All right. So here's how a deep learning looks like. So the network maps the input data X and makes a prediction. So here we have, oops. So here we have our input. This is our output, and this is our hidden layer. We call this the hidden layer. Those guys are also layers, but they're called the input layer, and this is your output layer. Now we could have more than just one single hidden layer. We can have many hidden hidden layers. So we first input the data to the input layer, and then we're gonna make predictions, cat or dog. Do the training, the predictions Y are compared to true targets Y using the loss function. So when we actually training this, and we already have the data, right? We're gonna be able to take the input, go through the layer. So let me actually do it. Yeah, go to the layer, first layer, go to the second layer, make a prediction, compare it to the actual data, and then go back, fix the weight value here, fix the weight value here, and then fix the weight value from the input X. So that's how it is worked. So we first go through the model, and then we're gonna make predictions by going back and fixing the weight values. So the last function, the quantity of the to be minimized during the training, the only thing the network cares about, that might also be the other metrics you are care about. So when we do the loss function, we're trying to minimize the loss function, the differences between the target and the prediction. We're trying to reduce that differences. And so how we do it is by figuring out the differences there, and then taking that and fixing our weight values for our the weight values coefficients for each layer. The common tasks have standard loss functions. We do the mean square error for regression, the binary cross entropy for the class classification, and the categorical cross entropy of multiple class classification. And then optimizing it. So what does that mean? It means that we're gonna try to fix the differences. You can see here in the diagram there, we have different types of models: the SGD, momentum, snag, and so on and so on. So what we're doing here is we're trying to minimize. We're trying to minimize the difference, the loss between the target value and the prediction. And we're using it to train our data so that we can actually land in the middle, in the center. Again, the diagram that represents the neural network. Some of the frameworks that we use for deep learning are Caffe, Torch, Chainer, PyTorch, TensorFlow, Caffe2, Theno, TensorFlow, DMC. So in our class, we're just gonna do TensorFlow. And okay, so now deep learning frameworks actually are tools for defining static or dynamic general purposes computational graphs, automatic differentiation, seamless GPUs, CPU usage for multi-GPU distributed. We mainly use Python and NumPy, and this is an open source. So let me actually go in here. So like I said before, there's many different data frames that we can use for deep learning, and we're gonna be focusing mainly on Keras, TensorFlow, and that mainly uses the GPU of a computer. So Keras is a high-level neural network API. We will use the TensorFlow as a compute backend. It includes the TensorFlow 2 as a TK Keras. PyTorch is a GPU-based tensor library, an efficient library for dynamic neural networks. So that's another tool that we can use for our deep learning. I'm gonna show you guys examples with Python where we can use this deep learning. Okay. All right. I'll see you guys next time. Bye.